There's only 3 commercial reentry vehicles in the world: SpaceX's Dragon, Boeing Starliner, and now Varda's capsule. And ours is by far the least expensive because it's not human rated. So if all you care about is reentry because you want to fly through the atmosphere at Mach 25 and test a new heat shield or test a new navigation system through the real environment, we're the only game in town.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year, but so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now. I'm Noah Scheinbaum, and this is Crossing the Valley. In less than 3 years, Varda Space has designed, built, flown, and successfully landed the world's first commercial space factory. They got it right the first time. And they've already won hundreds of millions of dollars in government contracts with the Department of Defense, NASA, and recently with the Air Force Research Lab. In today's episode, we caught up with Varda's co-founder and CEO, Will Bruey, at the Reagan National Defense Forum. Will started his career at SpaceX, where he was a hardware engineer working on the Falcon rocket and the Dragon spacecraft. He flew 8 flights to the International Space Station from mission control as the lead of the Dragon. He also worked at Bank of America Merrill Lynch as a director of global equities tech and went on to found Varda in November of 2020. In this conversation, we cover Will's experimental aircraft, manufacturing drugs in space, hypersonic test vehicles, and what other hard tech companies need to be successful. Enjoy. I am psyched to be joined today by Will Bruey, CEO, founder of Varda Space. I think the coolest company in the industry, and I don't usually say that publicly, but you guys are bringing sci-fi to reality. Thanks for being here, Will.
Thank you for having me. I'm psyched as well.
Awesome. So give us the why. Like, why does Varda need to be manufacturing drugs in space?
Yeah, absolutely. So microgravity is a unique environment. You can't create a lack of gravity on Earth. You have to be in free fall. You have to be in orbit. And so with more access to space comes more access to microgravity and access to that environment where you can do things like create formulations for pharmaceuticals that would otherwise be impossible to manufacture on Earth because of gravity. And so we can now unlock that. And that's Varda is lifting industrial operations off of our home planet in that way.
It sounds super cool, but for someone who's not that smart like me, why do we need to do that? Like, why does gravity even matter for manufacturing?
It's a great question. So I think of it like temperature. Like if we were to introduce refrigeration to the pharmaceutical industry, way back when, what does cold do for drugs, right? It's not that cold makes drugs better per se. It's not that microgravity makes drugs better. It just opens up the envelope. It's an extra knob to turn during the manufacturing process to create a formulation that would otherwise be impossible without that knob. So a good example would be the drug Keytruda, which flew on the International Space Station. And they showed that you can change the particle size distribution of crystals as they grow with that drug. That's Merck's highest revenue drug. And so with that type of technology, you can move a formulation from an IV bag, say, to a subcutaneous shot. And that means folks who can't get to a clinic for oncology drugs now have access to those type of drugs that didn't have it before, thanks to microgravity in this case.
It's pretty wild. It's just it's changing a form factor, changing a manufacturing environment just opens up more opportunity. Mm-hmm. Give us a little bit of the story of like how this came about. Because you were, SpaceX for many years. You also dabbled in the finance world a little bit. Where did the bio side of this come in?
Yeah, absolutely. So my co-founder, Delian, actually had the idea. So he is a partner over at Founders Fund, and they were early investors into SpaceX. And so when reusable rockets started to grip the road and really start to scale, he knew that manufacturing in space was now going to be a reality. And so he looked at other manufacturing and space companies to invest in and didn't see anything he liked. So he said, you know what if we do an incubation? I'll go find a founder instead. And so he was looking for someone with my profile who had worked at SpaceX, who had started other companies before, who was familiar with investment and this sort of thing. And we got connected, and I said, it was probably the easiest yes I've ever given. I was like, hell yeah, this is a great idea. So the first question, of course, is what are we going to manufacture in space? And it's pretty simple because from first principles, microgravity gives you the ability to manipulate chemical systems unlike any other way on Earth. Gravity is a fundamental force of physics. And so the most expensive chemical systems per unit kilogram are pharmaceuticals. And so, you get to help people as well. It's the obvious choice for the first substances to be manufactured in microgravity.
So if you strip it back to, you use the term first principles. I know it's a big founders fund term.
Mhm.
If we go back to first
Yeah.
principles, the thesis or the insight was around manufacturing something in zero gravity in space, and it was then like, what do we want to find?
Exactly. So with reusable rockets comes that accessibility to microgravity, and microgravity is a unique capability on chemical systems. So that's the whole foundation. That's really the only thesis of Varda is we can get to space cheaper and quicker now, and you can manufacture things that you couldn't manufacture on Earth.
It's one of the things as a total outside observer, right? I am not a space industry guy necessarily, and have not been to headquarters. But one of the things that kind of stands out to me is you guys just seem to be like a bunch of really smart people having a lot of fun. And it's like, even the way you're talking about it, it's like, wow, we can go to space and it's cheap and it's possible. What should we do with that? And it's like, I remember, was it last year? I think you guys were trying the experiment to like, do the rocks float? Like,
Right, yeah.
And all this stuff, you guys just seem like you're having a really good time.
We are having an absolute blast. It's hard not to if you think about. So we're a little bit lucky in the sense that this idea, even before Founders Fund initiated it, it's been around since the 60s of how can you use microgravity to manufacture pharmaceuticals. Crystals have been flown on the space shuttle for decades. It just never has been economical before. So the science is already there. There's no flux capacitor risk at Varda. So we know that there's a there, if you will, to use the DoD parlance. And so we know that what kind of the path there. It's pretty clear. And so we get to have a lot more fun on the way because we don't have to worry about if we're going the right direction.
It's kind of a wild thought for our audience that actually manufacturing in space there's no technical risk there. That's like, it's like it's known that's a safe thing to do.
Right.
When I think about Varda, I'm like, this is like a moonshot. But you're like, no, actually the technical risk is quite little. So where is the risk in it, I guess?
It's so it was in our first mission. And now we're scaling. So last year we had our first demonstration mission. Thank the launch gods, it was a success. That rarely happens in aerospace, so I pinch myself at how lucky we were. And now it's time to scale. And so really it comes down to execution at this point. The science has been de-risked on the International Space Station over the past decades. The platform has been de-risked via our first flight earlier this year. And the business is de-risked because it's actually a relatively simple business model, even though space drugs does sound kind of loopy. But when you look at it pretty coarsely, it starts to make sense quickly, especially if you use that mental model of what would you do if you're introducing refrigeration to the pharmaceutical industry. It's like, oh, same type of thing, just a different orthogonal dimension to temperature.
Yeah. Well, let's use that then as a jumping off point, because there's really, as I understand it, kind of two components to your business. And one is a commercial and kind of private sector focus. And the other is you guys are winning big deals with the government real fast. And so talk to us about the business model and maybe get into like what's the DoD or the government side of this whole thing.
Yeah, so we have we make reentry vehicles and the payloads inside them. So 90% of the CapEx, the employees at Varda, we're all building the same thing, those vehicles. And then the other 10% is, are we building them for the use case of defense, or are we building them for the use case of pharmaceutical manufacturing and pharmaceutical development? And so each of those two lines of business are very complementary because they use all that same capital investment. But that being said, the business models from a revenue generation perspective, are completely different. So for the hypersonic testbed use case, that was a perfect product market fit. It's a tale as old as time when a company and its technology merges with a customer and all of a sudden realizes that there's more customers like that.
Talk to us about that process, because crossing the valley, how do we move from these ideas, these concepts, to actually capabilities? What were your early conversations like with the government?
Yeah, it was a confluence of a customer, a sub portion of the government, AFRL specifically, that had a progressive mindset of really moving the needle in some new technology.
Yeah.
And they understand that reusable rockets means that we can get to space quicker, faster, cheaper. They understand that dual-use technology is something worth taking a bet on. And quite frankly, they took a bet on us. I mean, when we signed our first our contract with them, we were less than 100 people. We hadn't flown anything yet. We booked a launch and we had a spacecraft that looked like what we were eventually going to build. But they took a gamble on us. And there are pockets. The government is a huge non-monolithic thing, and there are pockets of real go-getters, and we got lucky in that our customer product market fit was one of those and took a risk on us and really paid off.
That's cool. So what was the first deal? Was it like a SIBR? Was it something else?
It was a SIBR phase 2. It's called a StratFi, strategic financing.
That was your first contract. Was a Strat?
Correct.
Wow.
Yes. Yeah. I guess first major contract. We had we had a few SIBR phase 1s and other small commercial deals, but this was the first one that was actually noteworthy on the balance sheet.
Yeah, fair enough. But still, you got there pretty quick, and so that program we've heard a lot about was when you think about what kind of gave them the confidence to say, hey, we're not just going to treat it as kind of this like early stage R&D effort. We're going to put real money behind it because we think there's something there. So they're there to take your word.
Yeah.
What do you think they looked at to say, this is legit? This is one of the bets we should make.
I mean, they're very smart. They looked at everything, right? Does the business model make sense? Does the system architecture make sense? Is the management team able to pull this off? Do they, I like that. One of my favorite stories is, so actually real quick before I tell my story, let me, the value prop that we offer the AFRL is a hypersonic test platform. So there's only 3 commercial reentry vehicles in the world, SpaceX's Dragon, Boeing Starliner, and now Varda's capsule. And ours is by far the least expensive because it's not human rated. So if all you care about is reentry because you want to fly through the atmosphere at Mach 25 and test a new heat shield or test a new navigation system through the real environment, we're the only game in town. And that's enabled by reusable rockets, that's enabled by new space coming up, and that's enabled by folks like the AFRL who are taking bets on that we can succeed. So, but going back to, they did their diligence on us like any other good steward of capital would. But my favorite story for the management piece specifically, I don't know how much this actually moved the needle, but in our minds, in Varda lore, it moved the needle. And so what happened was when we went to first meet our customer, it was a design review for this concept, and a lot of people flew in commercially, including our Air Force counterparts. And there's a lot of pilots at Varda, and we flew our own airplanes in, and it really set the tone of what kind of engineers we were. I fly an experimental plane, and I have to maintain and operate it because it's experimental. It's not FAA certified, so no technician will work on it. And so it says something like, okay, this is a CEO with a leadership team that maintains their own airplanes. They're in it.
They're not private
passionate,
jets.
right?
They're not flown in.
No. These are flying go-karts at best.
Where did you guys meet? Was this in where'd you guys go? This wasn't Rome.
This was in Logan, Utah. Yeah, so we flew up from LA and took a pit stop along the way. It was one of the fun adventures of early Varda lore. Yeah.
Tell us about your experimental plane, and what is the insurance policy on you flying that experimental plane?
That's a great question, and we need a commercial break here for the board of directors. So it's great. It's called a Cozy Mark IV. It's a Rutan pusher prop, so it's canard. The propeller's in the back, which is great. The Wright brothers had it right in terms of efficiency and speed. So it's a 4-seater. It goes about 200 knots, and it's great for business trips. Anything west of the Mississippi, it's actually faster to fly in this go-kart because you don't have to go through TSA or anything like that. You just drive over to the airport and hop in, and it is an absolute blast to fly.
That's amazing.
Yeah.
We're, some of our partners on this are the Atoms Not Bits guys. We give a shout out. They do great work on deep tech and hard tech content. These guys are going to want to come up in that plane with you.
Oh, please. I would love to. So the bottleneck to my flying habits is friends to fly with. So, I would please enable me.
So we're up here in Simi Valley at the Reagan National Defense Forum. Did you fly up here? I mean, not far from you.
So we were looking at it, but it's not far, and there is actually no municipal airport in this valley. So, but I did look.
Land on the highway over there.
That's
That's awesome.
I have actually, another funny story. I have landed on a Air Force base once, which is otherwise illegal, but it was an emergency. So my alternator died, and that's maybe a story for another story for another day. But
he's out there with a hammer knocking the thing out. So oh my gosh, that's
yeah.
wild, man.
Yeah.
Like I said, you guys are having a lot of fun.
we are. That's for sure.
I want to talk. Let's talk a little bit more about the government side of this, and then we'll talk about kind of the broader impact on the industry. When you think about AFRL, one customer. Where else are you guys looking? Where are all the other applications for what Varda is building, both from a reentry perspective and maybe even on the manufacturing side at the federal level?
Yeah. So back to first principles from a business perspective. You can think of businesses as arbitrations between you're taking something that's not as expensive and you're selling it for something that's more expensive, and you're doing something in between, right? So if you think about outer space for a second, there are two things that you get for free the second you separate from a Falcon 9 rocket. You get speed. You're going Mach 25 as you orbit the Earth. That's 18,000 miles an hour for free. And you get microgravity, which is also free, the second you get to orbit. And so these are two literally free things that are ubiquitous throughout outer space or throughout orbit that you cannot do on Earth. And so that's why we have those two lines of business. We're taking microgravity and we're selling it. We're taking speed and we're selling it. And so for the speed use case, the hypersonic testbed is just an absolute no-brainer because it is a national imperative to develop next generation strategic systems. It's imperative to develop hypersonics technology, and you cannot develop technology without testing it, and you cannot test hypersonics on the ground. You have to fly through the air. So if we are opening up the envelope of this test capability that otherwise the nation doesn't have, and the reason I love it, not just adding this capability to the nation that no other nation has, but it's built on a capability that no other nation has, which is reusable rockets. So you're really doubling down on a core competency that we have as Americans, and offering that for developing new technology. Like, the best way to develop technology is through test, and that's what we offer in terms of speed. So new heat shields, new navigation systems, learning more about the hypersonic environment through sensors and data. We get this at by far the cheapest and highest cadence. We want to fly one of these capsules at least once a day.
Wow. Once a day. And so the cadence you're at right now is not quite at once a day.
Right.
But how do you see kind of the process from where you are today to what has to be true for you to get to that volume?
So for that volume, the way to think about it is every other satellite company in the world treats their vehicles like capital investments. Sirius Satellite Radio, DirecTV, even Starlink. You put the constellation up, and then it makes money continuously. Now, what's unique about our reentry vehicles and our spacecraft is that we treat them as operational expenses, and so because they're more like a shipping truck than a capital investment, or than like a cell tower, for example, right? So what's neat about that is that if we can make just $1 after all the overhead on a per launch basis, then we can call up our launch provider and say the words, "We'll take as many rockets as you got, because the more we launch, the more money we make." Every other satellite company says, "We'll take as many launches as you got until our constellation is populated," and that saturates the demand for launch. Right. But if we're servicing a humongous TAM like the pharma industry, then we can just continue to scale without a saturation point of a constellation. And so the premise for the answer to your question, the direct answer to your question, is we just got to build it, because it's this cadence, it's a tinderbox that just lights itself from the unit economics. Whereas like every other space application, it's a little hard to understand how it'll scale because you have that saturation aspect. But with us, we don't have that. And so as long as we're making money on a per launch basis, the free hand of the market takes us from there. And there's every single drug is affected by microgravity. It's a fundamental force of physics. So it's not always worth going to space to improve a formulation. No question there. But, Keytruda at Merck is $15,000 a gram. So there are many drugs that are now economical to be made in outer space.
So is there a chance that launch itself becomes a constraint for you guys? Or is obviously SpaceX is ramping and growing, that business really well. Yeah. But as the space economy itself continues to develop, are you seeing any competition for space on those launches?
Well, there's certainly competition in the sense that we have purchased a slot on every Falcon rideshare mission out through at the end of 2026 to reserve our seats. So they're
This is what you're using all this capital you're raising.
exactly, yeah, exactly, saving seats. Yeah, luckily, it's only a down payment; it's not the whole thing and all that sort of thing. But that being said, I have full faith in the launch industry and especially SpaceX that if the demand is there, I just can't fathom, SpaceXers saying, "Oh, there's demand for more launch." Like right now, they're creating their own demand with Starlink.
Right.
So so I don't think they'll be too upset when we say we want. Yeah, I don't think so.
No, very cool.
Yeah.
I want to talk about the fact that while government now is buying your product, you guys have run up against some regulatory hurdles, right? And in I think a pretty interesting story last year, as you guys were ready to bring this first test flight back into the atmosphere, you spent what 8 months waiting to get clearance.
Yep.
So how do you have on one hand you've got the government ready, willing, able, excited to buy what you've got. On the other hand, you've got regulatory agencies that are like, hold your horses.
Oh, it gets even more. So like we were talking about earlier, the government is not some monolithic thing, right? And not even the Air Force is a monolithic thing. So our customer is the Air Force and our landing range is the Air Force. And we still needed to facilitate to make sure that we're doing the right thing by the landing range as well as the FAA and this sort of thing. So the reason it took much longer was first of all, it's just a brand new operation that neither of the three parties, being FAA, us, or our landing site, had ever done before. And so there was no process that guided how the landing range should facilitate with the FAA because they both have safety requirements. So which one takes precedent? And furthermore, which one takes the liability of the risk, right? So the reason why it took so long is we needed to check all the boxes for our landing site because our landing site says, hey, there's no legislation that says that we can rely on the FAA to take liability. If something goes wrong, it's an operation at our site, right? Now, the FAA is same thing. Hey, we can't, there's no legislation or policy that says that the landing range is going to take all the risk. So this might as well be a field, right? In terms of debris hazard analysis, right? So, and then facilitating between the two, added a n squared layer of complexity as well. So, but that being said, if on the one hand, it is awfully frustrating to be stuck in orbit for 6 months. So it was 8 months, but only 6 of them were the delay. We did intend to be there.
Intended.
Not that anyone's counting or anything.
Show.
Yeah. But if you think about it, okay, this is the first time that a small reentry vehicle has landed on U.S. soil, and it took 6 months for things could be worse. Things could be worse.
Here's the question I have.
Yeah.
Did you guys launch knowing we have no idea if we're going to be able to bring this back? Like, why was this not solved before you launched?
Great question. So what happened was we had express written permission from the FAA to launch without the license in hand for the first one. And the reason for that was everyone intuitively knows that this capsule is very small and not a huge risk, but it's not what it's like in Training Day. Denzel Washington says, it's not what you know, it's what you can prove, right? So the regulations say you need to prove public safety, right? So everyone kind of knew, but we still had to go through the paperwork. And then what was not really foreseen by any party was the fact that all the facilitation between government entities that have never had to do this operation before, and there was no procedure to do it. So, going off script as a government entity is usually a huge no-no. And so we had to really facilitate and foster doing this for the first time. Now, when we do it more and more, it's going to become relatively easier. And this same thing happened with launch, like with the eastern and the western ranges being Vandy and the Cape. They had to have legislation between the Air Force and the FAA to essentially say, hey, on range, you own the liability of debris, and off range, FAA owns the liability of the debris. But that legislation didn't go to our landing site, which was neither of the launch ranges.
That's wild.
So we had so we're working on kind of making that copy paste for other potential spaceports.
So if I read back to you, what I think I heard is like, you thought it would be okay, but then it was kind of like, devil's in the details. Things didn't exactly play out.
Exactly.
The old Mike Tyson punched you in the face.
Right.
And you guys ultimately landed. So future landings, U.S. or we're going elsewhere?
So we would love to land in America because it's for no other reason than national pride,
And you guys are very good at this. Your co-founder Delian is very much an online person with his
Yes,
with
yes.
his American pride, which is
Yeah.
awesome. I think it's great. But
So for the next few missions, we are landing in Australia because they have a commercial range in Kaniba, and so we are a priority there. Whereas to no fault of any of the domestic ranges, their priority is not commercial capsules. Their priority is training warfighters and testing weapons, right? So we take a back seat, and if we get bumped for a higher priority, it takes a long time to recycle that reentry. So, but for our Australian partners, it's commercial, and so it's more of a pull from them. That being said, we are working to develop both the regulation and the analysis to do especially defense missions, have those land in America, because we should be able to do it. We should do it. It's just a matter of time and doing the work.
awesome. I know we're kind of we don't have too much time. I want to look to the future a little bit. Like I said, we're here, beautiful Simi Valley at Reagan Defense Forum. There's many of the congressmen and potentially senators who you need to pass some of this legislation are here. What's your message to the policy making world about, like, what does Varda want to see? Sorry, not a lobby. This is not a lobbying question. What are some of the changes you're hoping to see maybe in the next administration that make it possible for you guys to go even faster?
So the biggest one is just having the first thing is having a contract or a legislation, if you will, between our landing site and the FAA to understand where liability is, so that neither party feels like they're taking on all the liability. So that's number one. Number two is recognize how significant this technology is. Like we were talking about earlier, we are building a unique national asset on top of a unique national asset. So the fact that we can test our hypersonic test bed, no other nation can do that at our price or our cadence. And so if you want a new generation of strategic systems, if you want first generation hypersonic vehicles, this is a huge unlock, and it's non-obvious until you look. So I guess really the other thing to say is just like, check out Varda and look what it's doing, and it will click if you pay just 5 seconds of attention of how we're able to create this hypersonic testbed that never existed before. It makes a ton of sense why it didn't exist before. It makes a ton of sense of how it works. It's borderline obvious, and I think that when that clicks for folks, they'll be I mean, you're already seeing this, a lot of supporters helping us. Basically every time we see a representative here at Reagan, it's always a thank you handshake. So everyone who has learned about us is super supportive, and I think it's just a matter of time as that notion swells.
Yeah. Given your focus on the hypersonic piece, I did want to get your thoughts on that specific kind of technology or even domain to some extent, where the narrative has been for years that the U.S. is behind in hypersonic development, especially on missile systems, weapon systems relative to Russia. We saw a few months ago, Russia used, which maybe not an ICBM, maybe hypersonic, maybe not, but a weapon in Ukraine that is not like anything the U.S. has ever kind of deployed elsewhere, with multiple reentry vehicles. And I'm kind of curious as you look at that, why do you think we are? Are we behind? Why do you think, if so, why would we be behind in that?
It's actually funny. Karp, CEO of Palantir, was just talking about this. We get a little bit lazy. Every person who's in first place or in the lead gets lazy. It's a negative feedback loop of competition. And so I think that, for the last 30, 40 years, we had a great deterrent system that is now not as clearly, obviously a generation ahead where you don't even have to think about it. So that's part of it, just the fact that you've always got to step on your toes or be on your toes, and you've always got to step on the gas, even when you don't see anyone in the rearview mirror. So that's part of it. I think the other part of it is that it actually goes back to testing. Most of those reentry vehicle technologies, heat shields, navigation systems, arrow shapes, all of that is from the Apollo era, because you can't test hypersonics on the ground. And so the only hypersonics that have flown like that are Apollo type vehicles. And so now that we have reusable rockets and we can now deploy Varda capsules at scale at low cost, it just comes down to the fact that if you want to build reentry technology, if you want to build hypersonics, you have to test them. And the only way to test them is fly through the environment. And now Varda is unlocking that environment at mass, at scale, at cadence.
So paint us a picture of what, as Varda gets only more and more successful, and we fast forward kind of a couple of years, what does the world look like with Varda as the full potential beast? Like, are you all building hypersonic missiles? Are there other business areas that you're expanding into, or does it just, the world looks different because everything is now manufactured in space?
Let's see. So I'll paint the like 5 to 10 year
Give us
picture,
5 to 10,
right?
and then we
The
can
21's a little different, 20 years. So 5 to 10 years.
Before you're the president, but let's not go that far. Yeah.
So the thing I tell the team, and I tell everyone, is like, if there is one binary metric of is Varda a successful company, it will be if you can go to one of our landing sites and see more than one shooting star of a capsule come in per night. If we hit the daily cadence, we have been successful. And what that looks like, and that's very uncrazy. And the reason why it's not crazy is because there is more than one Starlink satellite launched on average per day, well more than one. And our vehicles are about the same size and complexity. And so we just have to build them. And so anyways, one per day. And what's on board is either a new batch of developing pharmaceuticals or a defense payload for testing hypersonics, testing navigation systems. It's like a wind tunnel, right? You're always going to want wind tunnels, even when you iterate on wing design and airplanes. Wind tunnels, it's never like, oh, I now understand wind and I'm never going to use a wind tunnel again, right? You have to test everything that you develop. And so that's true for us. And so we'll have a portion of our capsules are not just pharmaceutical batches, but are hypersonic tests in the same way that you would have a wind tunnel test. But what it looks like is just shooting stars of capsules. I mean, shipping to space is truly becoming just shipping. And Varda will be the first routine manufacturing operation off our home planet. We start small with pharmaceutical molecules, but eventually we will then add upon. That's the 20-year dream. Is okay. Let's now put a larger station up there and make materials that aren't just pharmaceuticals. But that's really where we hit the inflection point of this positive feedback loop, where the more we launch, the more drugs we can make, and therefore the more drugs we can make, the more we launch vehicles.
No, it's an inspiring mission. Super, super cool. I want to ask you one question about the business side of things. Which is, you guys are building a company that's just growing really fast. Not growing necessarily in the way that the venture capital world talks about growth, which is like raise a bunch of money, hire ahead of growth, and then we'll kind of earn our way into the valuation. You guys are legitimately making massive progress very, very quickly. And I'm kind of curious, from first principles, like, what is allowing you all to operate at the speed of iteration and growth that you are, and like what do you think that means for some of the other maybe startups or aspiring founders who might be here who are thinking about entering this industry?
The key is be 100% sure in your thesis, which we went over, right? For Varda, and then do the simplest thing possible. So many more startups fail trying to do more than trying to do the bare minimum to hit your thesis, right? So if we can create the cheapest hypersonic test for our government partners, and we do so by cutting all the scope with ridiculously simple systems, like rock simple systems, then it's a matter of, it's just less ways that you can fail. And so since there's less ways that you can fail, you can grow faster.
Awesome. We will leave it there. Will, thank you for making the time. If folks are listening, they're excited about the mission that you're on. If they want to join, they want to learn more, where should they go?
Varda.com/careers, jobs at Varda.com. And if you want to get aggressive, it's Will at Varda.com. And we're hiring, something like 79 people this year. So come on down. It's a ton of fun, and it's a challenge. It's a real challenge. It's awesome.
Thanks for making the time, Will.
Thank you so much, Noah. Yeah, absolutely.